Hi, everyone. Welcome back to Mathematics for Engineering 3 International Program for students at Kasetsart University. Today, we are going to begin Chapter 3, which is a Laplace transform. Okay, and here, if you look at the lecture notes, it's a little bit different than what we had before, because many of you have asked me to type the lecture notes because my handwriting is quite hard for many of you guys to read. So I decided to type the lecture notes so that it will be easier for you all to read. And okay, let's begin. First, let's look at the outline of chapter 3. First, we are going to learn the basic Laplace transform. I believe that many of you haven't heard of the word Laplace transform before. So, in the first topic, we are going to talk about what Laplace transform is, and how to do the Laplace transform. And after that, we're gonna look at the techniques to do the transform easily. Okay, what are the formulas, the techniques that we can use to basically to do the Laplace transform. And that is this is really important section. The third one would be the basic inverse Laplace transform. Okay, in the first chapter we learn how to do the Laplace transform, and after that we're going to do the inverse Laplace transform. Okay, don't worry about that yet. The reason I put them here, because so that you can look at the overview of the chapter. And the fourth one is similar to the second one, so we look at the techniques of the inverse Laplace transforms. And why do we need to study Laplace transform? Is because it can be used to solve the ODE problems. So in the fifth chapter, we're going to be looking at initial valued problems and how to use Laplace transform to solve them. Okay, and boundary valued problems and integral equations. Okay, so those are the 7 topics that we're going to be looking at in this chapter. Okay, let's begin. First, what is Laplace transform? Okay, it's some sort of transform. It means that it need to change one thing to another thing, right? That's the word transform mean, right? So the definition here: let ft be a function. Guys, be careful, it's a function of t, not x. Okay, usually when we talk about function, we usually say fx, or I don't know, gx, or something x. But in this chapter we're going to be looking at ft. Okay, so ft is a function of t. It's a function of t, and defined on the positive interval. Okay, it's defined on the positive interval, non-negative, I should have said non-negative interval. The Laplace transform of ft is defined by this expression. So basically, if you have ft, here is the expression for Laplace transform of ft. Okay, which is L, stands for Laplace. Okay, and then f, Laplace transform of f, is actually integrate 0 to infinity of e to the minus st ft dt. Okay, and we call that f of s, the big F of s. Okay, note guys, if you look here at this expression, you have ft, right? You have ft, and you integrate, you integrate dt, right? You integrate dt. It means that there's no t anymore. Make sense? Make sense? You integrate dt when t is from 0 to infinity. Guys, look at this. If you remember, integrate 0 to 3 of x squared dx, you get x squared. Okay, let's use t squared dt, you get t cubed divided by 3, and then 0 and 3, so you get 3 minus 0, which is 9, right? So basically, when you integrate dt, when t is from some number to some number, you don't have t anymore. That's why Laplace transform of ft is not a function of t. It's not a function of t. It's actually a function of s. Okay, because you have s here. See that? You have a little s there. So, when you integrate by t, you take s as a constant. Okay, so you don't care about s. It's seen as a constant. So you integrate dt. Okay, ft, or the Laplace transform of ft, is actually a function of s. That's why we call it fs. Okay, let's look at some examples. First, find Laplace transform of 1. It means that right now our ft is actually 1. Okay, so we need to find the Laplace transform of 1. Cool. So if you want to find the Laplace transform of 1, we look at the definition here. Okay, I copy and paste it here so that you can observe it here easily. So the Laplace transform of 1 is basically integrate 0 to infinity e to the minus st, and then ft is actually 1, isn't it? So you have 1 here as an ft, and then dt. Okay, and if you want to integrate this function, you need to take limit, right? It's improper integral, right? It integrates from 0 to infinity. You can't really integrate to infinity, so you need to do this. It's actually limit a approaches infinity of integrate 0 to a e to the minus st dt. Okay, so basically it just the way to do it. It just that you need to integrate from 0 to a, and then you let a goes to infinity. Okay, and then the e to the minus st dt. And to integrate this function, from calculus 1, integrate 0 to a e to the minus st. So id minus st. Okay, but guys, d minus st is actually minus s dt, right? So dt would be d minus st divided by minus s. Okay, so you need to divide this by minus s so that you recover the same expression. See, because dt is actually d of minus st divided by minus st. Okay, and here it's pretty much the same as e to the u du. See, that's the integration by substitution. I hope you guys know how to do it from calculus 1 or from math 1. Okay, so you do substitution. So here we have that it's actually minus 1 over s. Okay, 1 divided by minus s is actually minus 1 over s. Okay, it's the same thing. Limit a approaches infinity, integrate e to the minus st d minus st, you get e to the minus st from 0 to a. Okay, and in that case you have minus 1 over s limit a approaches infinity of e to the minus at minus 1, right? E to the 0 is 1. E to the 0 is 1. So if you let a approaches, oops, sorry, my bad. You need to substitute a into t, not s. So it's sa. Okay. So if you take a approaches infinity, this expression, if s is less than 0. Okay, let's look at the case when s is bigger than 0. If s is bigger than 0, okay, when a approaches infinity, e to the minus sa approaches 0. Make sense? Because if s is positive, e to the minus infinity is 1 over e to the infinity, which is 1 divided by infinity, which is 0. Okay? Okay? Make sense? Make sense? But if s is less than 0, if s is less than 0, okay, if s is less than 0 or less than or equal 0, we will have that. Okay, let's look at when s is less than 0 first. E to the minus sa. So if s is negative, it means that minus s here is positive. So if minus s here is positive, a approaches infinity times positive, it means that e to the infinity goes to infinity. Make sense? Make sense? So if s is positive, e to the minus sa is 0. If s is negative, e to the minus sa goes to infinity. If s is 0, you have 1 over s here. So 1 over s would go to infinity, right? It go to infinity or minus infinity. We don't even know that, right? Because it depends if s is 0 from the right hand side or 0 from the left hand side. So we can say that it converges only if s is positive, right? It converges to 0 only if s is positive, which means that this integration is minus 1 over s, and here we get minus 1, which is 1 over s when s is positive. Make sense? Make sense? Okay, because otherwise if s is not positive, this integration, this limit will go to either infinity or minus infinity, and we can't really find a value. So when you do the Laplace transform, this is quite important as well. You need to know when it converges. Okay, in this case it converges when s is positive. Make sense? Okay, this is to compute the Laplace transform by definition. Okay, we basically look at the definition, which is in terms of improper integral. Improper integral means that it's integrate from something to infinity, or infinity to something, or it can't be evaluated at some point. Okay, so we do the integration, and once we do the integration, we need to compute the limit, right? A approaches infinity, so we need to look at the cases when when the limit converges. Okay, and in that case we have it here. Make sense? Cool. So next example, find the Laplace transform of e to the minus 3t. How to do that? Same guys, it's the same. L of e to the minus 3t t is actually integrate 0 to infinity of e to the minus st e to the minus 3t dt. Okay, so basically we just put this in ft. Make sense? Make sense? I'm not sure if the line is too thin, so let me make it a little bigger. Yeah, so here we have that is the limit a approaches infinity, integrate 0 to a e to the minus s minus 3, and then you have t here dt. Okay, let's do it even slower. So we get minus st minus 3t dt. Make sense? Make sense? And after that it becomes e to the minus s plus 3t dt. Okay, so if you want to integrate this function, it's 0 to a, my bad. So if you want to integrate this function, you need to do substitution, right? You consider a as a constant. Sorry, you consider s as a constant. Okay, so here limit a approaches infinity, integrate 0 to a e to the minus s plus 3 t d of minus s plus 3 t divided by minus s plus 3. Guys, again, here is from the substitution. Okay, it's from the substitution. We have that d of minus s plus 3 t is actually minus s plus 3 dt, which means that dt is actually d of minus s plus 3 t divided by minus s plus 3. Okay, so we substitute dt by d of minus s plus 3 t divided by minus s plus 3. It's the same as to do substitution, let u be minus s plus 3. Okay, but we are grown up, so I'm not gonna do that. Okay, just gonna write like that. So here I'll just pull this guide here, so we have 1 minus 1 over s plus 3. Okay, guys, 1 over minus s plus 3 is the same as minus 1 divided by s plus 3. Okay, you can move minus 1 up. Okay, so is limit a approaches infinity and integrate e to the u du. That is actually e to the u, right? Integrate e to the u du is e to the u. So here is e to the minus s plus 3 t. T is from 0 to a. So we have minus 1 over s plus 3, and then is e to the minus s plus 3a minus 1, which is e to the minus s plus 3 times 0, right? And in that case, we have that. Oops, sorry, I forgot the limit. limit a approaches infinity. So if you take a approaches infinity, that guy is going to converge if and only if it's converge if and only if s plus 3 is positive, which means that s is bigger than minus 3. Okay, which means that s is bigger than minus 3, right? Because if this part is positive, if a approaches infinity, e to the minus positive a is going to converge to 0. Okay, and in that case we have that it is minus 1 over s plus 3, and here we have 0 minus 1, right? Because the exponential e to the minus s plus 3a approaches 0 as a approaches infinity. So we have that is 1 over s plus 3 if s is bigger than minus 3. Okay, if s is bigger than minus 3, and that is the Laplace transform of e to the minus 3t. Okay, cool. Okay, next example, find the Laplace transform of t e to the st. Okay, so guys, it's the same. We just begin with the definition. Okay, guys, in the exam, I'm not sure if this is going to be in the exam. It might be too easy to be in the exam, to find the Laplace transform using definition. But if it is in the exam, first, if you don't know what to do, just write down the definition. Okay, at least you get some some points. Don't just leave it blank. Okay, so here the Laplace transform of t e to the 4t is integrate 0 to infinity e to the minus st, and then you have t e to the 4t dt. Okay, so basically you put this guy in here in ft, right? Makes sense. And after that, it is the same, guys, the same. We take limit a approaches infinity, integrate 0 to a t e to the minus s minus 4 t, and then dt. Okay, let me do it a little slower. So it is minus st plus 4t dt. So here is limit a approaches infinity 0 to a t e to the minus s. I pull minus s out. So what I have here is t sorry, I pull minus s out. So I have, okay, let's just pull minus 1 out, sorry. So I have s minus 4 t dt. Okay, and how to integrate that function, how to do integration for that function. Okay, first let's just observe this integration, without the 0 and a, just this integration. And then I let u be minus s minus 4. So we have that du is actually minus s minus 4 dt, right? Oh, I have t as well here, t here as well. So du is minus s minus 4 dt, and t is actually u divided by minus s minus 4. Okay, just just push this guy down here, so we get that. So this integration becomes integrate t is u divided by minus s minus 4 e to the u dt is actually, guys, here dt would be du over s minus 4. So we have du divided by minus s minus 4. Get that? Okay. So we have that is integrate 1 over, okay, let me pull the constant out. So we have 1 over s minus 4 squared. Okay, because we have minus 1 here, they cancel out. So we have s minus 4 squared. And then is integrate u du. Sorry, u e to the u du. And to integrate that, we need integration by part. And here we take u and e to the u. So we have 1, 0, e to the u, e to the u. And then here we have that plus minus. Okay, plus and minus. So this integration becomes u e to the u minus e to the u, which is 1 over s minus 4 squared. U is, what is u? U is minus s minus 4 t e to the minus s minus 4 t minus e to the minus s minus 4 t. Okay, and that is the integration. Make sense? So we have that is actually minus 1 over s minus 4 t e to the minus s minus 4 t. Okay, basically I distribute this back inside, and we have that is minus 1 over s minus 4 squared e to the minus s minus 4 t. And after that, we come back to look at this integration, which is limit a approaches infinity of integrate. That integration would be minus 1 over s minus 4 t e to the minus s minus 4 t minus 1 over s minus 4 squared e to the minus s minus 4 t from 0 to a. Okay, it will be from 0 to a. So in that case, we have it is limit a approaches infinity, and then we take a in there. So basically we have minus 1 over s minus 4 a e to the minus s minus 4 a minus 1 over s minus 4 squared e to the when we take a, we get minus s minus 4 a, and after that we put 0. Okay, we subtract it by letting t be 0. This part becomes 0 as t is 0. So we have only this part, which is minus of minus 1 over s minus 4 squared, and that's it. Okay. and then I'll take this to the next page. So here we have that. Okay, let me make it a little bigger. We have that. It is, what is it? Minus limit a approaches infinity of, what is it? Minus 1 over s minus 4 a e to the minus s minus 4a minus 1 over s minus 4 squared e to the minus s minus 4a plus 1 over s minus 4 squared. And guys, to make this limit converges, again, s must be bigger than 4. Okay, why? Because we need this part to be positive. Okay, it's the same argument. Okay, and s can't be 4 because otherwise this is 0. Okay, so here we have that is minus of, oh sorry, it's not minus here, there's no minus there. If you look here, it's no minus. So we have that. We take as a approaches infinity, here it becomes 0 minus 0 plus 1 over s minus 4 squared. Okay, so it is 1 s minus 4 squared when s is bigger than 4, and that is the answer. Make sense? Okay, so basically here we need to integrate this guy, and it's quite messy here because it's not about the Laplace transform, it's about integration, because we need to do integration by part. First we need to do substitution, and when we see this guy we need to do the integration by part, which is this guy, and then we substitute them back. After that, you know, this integrate is the same as that integrate, put them here, and then we substitute t with 0 and a. Okay, so we put a here, we put a here, and when we put t equals 0, this guy disappeared because it's, you know, it's times t here. So we only have this part. Okay, make sense? And after that we compute the limit a approaches infinity, and it converges if and only if s is bigger than 4, and in that case that is the solution. Okay, next example. Here, find the Laplace transform of this function. So it's the same, guys. The Laplace transform of psi t is, what is it? Laplace transform of psi t. It is integrate 0 to infinity of e to the minus st. Sorry, I shouldn't write psi t. I should write ft. So it's ft dt. Okay, that's the definition. And after that, it's integrate 0 to pi e to the minus st. Ft is sine t dt plus integrate 0, pi to infinity of 0 dt. It's e to the minus st 0 dt. Okay? Okay. And guys, it's actually limit, it's actually integrate 0 to pi e to the minus st psi t dt plus limit a approaches infinity, integrate pi to a e to the minus st dt times 0 dt. But guys, this expression seems to go to 0. Okay, it goes to 0 because it's 0 times e to the minus st. But you need to be very careful. You need to be very careful. Why? Because if a goes to infinity, e to the minus st, okay, let me write down. If s is positive, and if s is negative and a goes to infinity, we have that e to the minus st goes to infinity. So e to the minus st times a is an indeterminate form. Okay, it is actually infinity times 0. Times 0 here. It infinity times 0. So you need to be very careful here. Okay, so we need to have that s must be bigger than 0. Otherwise, you can't really evaluate this expression. Okay, again guys, if s is negative, when a approaches infinity, don't forget guys, when you integrate this, you're gonna get, you're gonna substitute a in there, right? And a approaches infinity. So if a approaches infinity, e to the minus st approaches infinity, right? So once a approaches infinity, e to the minus st approaches infinity as well. Okay, here a approaches infinity is the same as t approaches infinity. Okay, so in that case, e to the minus st times 0, this part is going to go to be infinity times 0, which is indeterminate form. Okay, so we need to get rid of that situation, which means that we need to say that s is always positive. Okay, so here, if s is strictly positive, this guy can't be infinity, right? It needs to be number, right? So in that case, it is 0. Okay, so here we have here that is integrate 0 to pi e to the minus st psi t dt. Okay, and if you want to integrate that function, guys, I'm not going to integrate this function anymore. Okay, you can try it using the integration by part techniques. Okay, you can integrate that function, and I'm just gonna give you the solution. It minus 1 over s squared plus 1 s e to the minus st psi t plus e to the minus st cos t 0 to pi. Okay, and after that you do substitution. You get, you substitute t with pi, so we have, what is it, s e to the minus s pi, but psi pi is, what is it, psi pi, but just write down psi pi for now, plus e to the minus s pi cos pi minus s e to the minus s pi s0, which is e to the 0, right, psi 0 plus e to the 0 cos 0, and here we have that is minus 1 over s squared plus 1. Psi pi is 0. Cos pi is actually minus 1. Cos 0 is 1. Psi 0 is 0. So what we have left here is minus e to the minus s pi minus, here you need to distribute minus in there, so we get minus 1. Okay, so in that case we have that it is e to the minus pi s, or s pi, let's say s pi, minus plus 1 divided by s squared plus 1. That is, you need to multiply this in there. Okay, when s is bigger than 0. Guys, this part is quite tricky. You need to be very careful. Okay, because if s is greater than 0, sorry, if s is less than 0, we would have that here is going to be indeterminate form. Okay, this multiplication is going to be indeterminate form, which is infinity times 0. So in that case, s needs to be bigger than 0. Okay guys, and as you may already feel, that is quite, it's quite messy to do the Laplace transform, right? We need to integrate and then, blah blah blah, the limit and things. So here we have the table of Laplace transform. So basically you have fundamental formulas for the Laplace transform. Okay, so basically if you want to do the Laplace transform for 1, you get 1 over s, and s is bigger than 0. If you want to Laplace transform e to the kt, you get 1 over s minus k, s bigger than k. Okay, and the Laplace transform of t to the n is n fact divided by s to the n plus 1, s bigger than 0. Laplace transform of psi kt is k divided by s squared plus k squared, s bigger than 0. Laplace transform of cos kt is s divided by s squared plus k squared, s bigger than 0. And Laplace transform of psi kt is k divided by s squared minus k squared, s bigger than absolute k. And Laplace transform of cos kt is s divided by s squared minus k squared, s is bigger than the absolute k. Okay, but you don't need to worry because these formulas are provided in the exam. Okay, so you have these formulas in the exam. So if you see like these sort of functions, and if you want to do the Laplace transform for any of these functions, you don't need to do integrate 0 to infinity e to the a minus a st blah blah blah. You don't need to do them. Okay, you just need to use this table and your life is going to be much easier. Okay, And guys, this one thing, the Laplace transform is actually linear operator, which means that if you want to compute Laplace transform of f plus or minus g, you can do it by computing Laplace transform of f plus or minus Laplace transform of g. And if you have the Laplace transform of kf, when k is a constant, okay, k here is a number, you can pull the k out and then you find the Laplace transform of f. Okay guys, let's practice using these formulas. So find the Laplace transform of ft, which is 3x to the 5 minus 6x x minus 3t to the 5 minus 6t cubed plus 7 plus cos 3t divided by 2 minus 4e to the minus 2t. Okay, let's find Laplace transform of this. Guys, it's not going to be fun. Okay, it won't be fun if you need to evaluate, integrate 0 to infinity, and then you have using these formula, integrate 0 to infinity e to the minus st, and then you have this guy as a ft. It's going to be a long process to do the Laplace transform, right? But if you have these formulas, it's going to be a lot easier. Okay, let's have a look here. So you want to find Laplace transform of 3x to the 5 minus 6t cubed plus 7 plus cos 3t divided by 2 minus 4e to the minus 2t. Okay, and as I told you, the Laplace transform is linear. It's a linear operator. So it means that here you can take the Laplace transform of L, right? It's a Laplace transform of 3t to the 5, but you can pull t out because 3 is a constant. Okay, so you have Laplace transform of t to the 5 minus 6 Laplace transform of 3 cubed plus 7 Laplace transform 1 plus Laplace transform of cos 3t divided by 2 minus 4 Laplace transform of e to the minus 2t. Okay, and in that case we go back to look at the formula. The Laplace transform of t to the n is n fact divided by s to the n plus 1. So we have here it is 3 5 factorial divided by, what is it, s to the n plus 1. So we have s to the 5 plus 1, which is 6. Make sense? And then minus 6. Here we have 3 fact divided by s to the 4. Okay, plus 7. Laplace transform of 1 is 1 over s. Plus Laplace transform of cos 3t over 2. So here we need to use this formula, right? Okay, so we compared it with cos kt. So our k now is actually 3 over 2. Okay, so the Laplace transform of cos kt is s divided by s squared plus k squared. So we have is here is s divided by s squared plus 3 over 2 squared. Make sense? Minus 4 Laplace transform of e to the minus 2t. E to the minus 2t, we need to use this formula, e to the kt. e to the kt. But right now it's e to the kt, which means that k is actually minus 2. Okay, k is actually minus 2. So the formula is 1 over s minus k. So it's going to be 1 over s minus 2. Guys, be careful. K is minus 2. It's 1 over s minus k. So it needs to be 1 over s minus 2. So here we have that is 3, 5 factorial, 6, s to the 6, minus 6, 3 fact s plus 7 over s plus s divided by s squared plus 9 over 4 minus 4 divided by s plus 2. Okay, and here we have that it's 3 factorial times 5 factorial is 5. Guys, 5 fact is 5 times 4 times 3 times 2 times 1. Okay, and here is 20. Here is 6, so 120 times 3 times 3, that would be 360 s to the 6 minus here would be 36 divided by s to the 4 plus 7 divided by s plus s divided by here we need to multiply it by 4 and 4. So we have 4s squared plus 9, and then you have 4 here minus 4 divided by s plus 2, and that is when s is bigger than 0. Okay, that's when s is bigger than 0. Make sense? So see, it's a lot easier than using the definition, right? Integrate 0 to infinity e to the minus st ft dt. That takes forever. Okay, here is a lot easier. Okay, let's look at the next example. Here, guys, here we have this guy squared. We have this guy squared. Okay, so we can't really take the Laplace transform inside the squared here. We can't really do that because the Laplace transform of f plus g is Laplace transform of f plus Laplace transform of g, right? But Laplace transform of fg, okay, if it's a product, we can't split it. Okay, we can't really split the Laplace transform of fg. Okay, we can't do that. So here, what you need to do is that you need to evaluate the square first, and after that we just apply the fundamental formula. Okay, so here what we have is Laplace transform of okay, first let's evaluate this guy. And what is it? What is that, guys? We need to use this formula, right? A plus a minus b squared, and that is a squared minus 2ab plus b squared, right? So in that case we have that is e to the 2 3 minus 6 e to the 3 over e to the minus 3t plus 9 e to the minus 6t. Okay, makes sense? Okay, you look at this guy as a and this guy as b. So you have a squared. Okay, that is a squared. Okay, e to the t divided by 3 squared. Okay, you have x to the a to the b is x to the ab, right? So the squared, the number 2 time is going to time the t divided by 3. Okay, and similarly here, we have 2 of a and b, but b you have 3, right? You have 3, but you have 2 here, so it becomes 6. And then here it's actually b squared. Okay, it's b squared. Because this guy is squared, you need to get 3 squared and e to the minus 3 squared. And when you push it here, you get this. So the Laplace transform of e to the t over 3 e to the minus 3 squared is the same as the Laplace transform of e to the 3 divided by 3 minus 6 e to the 3 over 3 minus 3t plus 9 e to the minus 6 3. Okay, and that is Laplace transform of e to the 2t over 3. Okay, can I write it like this? 2 over 3t, and then minus 6 Laplace transform of e to the here guys, t over 3 minus 3t, then you need to multiply 3 here, right? So you get 3 over 3 minus 9t divided by 3, and that is minus 8 3 divided by t. So you have here minus 8 t divided by 3 and plus 9 Laplace transform of e to the minus 6t. And guys, don't forget we have the formula. The Laplace transform of e to the kt is 1 over s minus k. Okay, we have the formula. The Laplace transform of e to the kt is 1 over s minus k when s is bigger than k. Okay, when s is bigger than k. So we have here the Laplace transform of this guy would be 1 over s minus 2/3. Okay, here we have the condition that s is bigger than 2/3. Minus 6 1 over s minus 8, and we have here s must be bigger than minus 8. And this one we have plus 9 e to the 1 over s minus 6. So here we have s is bigger than minus 6. Okay, so guys, we have 3 conditions from each term. We have 3 conditions from each term. So in order to have only one condition, you need to take the intersection of the 3 conditions. Okay, so if you look here at the real line, you have minus 6 here, you have minus 8 divided by 3 here, you have 2 over 3 here. So for this condition, it says that s need to be bigger than that. This condition, it says that s need to be bigger than that. And for this condition, it says that s needs to be bigger than that. So if you take the intersection, it means that s needs to be bigger than 2/3. Okay, s needs to be bigger than 2/3. And in that case, we have that it is 1/3s minus 2. Okay guys, multiply 3 here, multiply 3 here. So here is going to be 3 minus 6 1/s plus 8 divided by 3 plus 9/1 plus 6. So here I multiply 3 here, 3 here, and I get that is 3 divided by 3s minus 2 minus 6 times 3, that is 18, divided by 3s plus 8 plus 9 divided by s plus 6 when s is bigger than 2/3. And that is the answer. Okay, that is the Laplace transform. Okay guys, I'm so sorry. We need to go back to the previous question. Okay, I did it correctly, but I forgot to explain one of the really important things to you. Okay, here when we do this Laplace transform, okay, we have the condition that s need to be bigger than 0. Okay, if you don't forget the Laplace transform of t to the n, we have s bigger than 0. Okay, here as well, t to the n, we get s bigger than 0. Laplace transform of 1, we get s bigger than 0 as well, s bigger than 0. Laplace transform of cos 3/2t. So Laplace transform of cos kt, we have the condition s bigger than 0 as well. So here, this one we also have s bigger than 0. Laplace transform of e to the kt, we have that the condition is that s is bigger than k. S is bigger than k. But the k here is minus 2. Right? Minus 2. E to the k. Here, guys. So this one we have the condition that s must be bigger than minus 2. Okay? S is bigger than minus 2. Make sense? So we need to take the intersection of all conditions. So if we look here, we have 0 here and minus 2 here. You know, for most of them, it says that s is bigger than 0. Okay, but the last one, it says that s needs to be bigger than minus 2, which means that the intersection would be from 0 to infinity. Okay, that's why we have this condition there. But I'm so sorry, I forgot to explain that to you. Okay, but the answer is correct. It's similarly here, when we did the Laplace transform of ft equals this function, right? We first do we just distribute the squared and we get this function, and after that we just take the Laplace transform inside, okay, because it's linear operator. Okay, and here is the Laplace transform of e to the kt. Laplace transform of e to the kt. We have the condition that s must be bigger than k. So here we have the condition that s is bigger than 2/3. And similarly here, we have the condition that s is bigger than minus 8/3. And here we have the condition that s is bigger than minus 6. And because we have so many conditions, we have s bigger than minus 6, bigger than minus 8, and minus 8 over 3, and bigger than minus 2 over 3. We need to take the intersection, which means that s is bigger than 2/3. Okay, we need to take the intersection, because this Laplace transform would work if and only if all conditions are satisfied. Okay, it needs to satisfy all conditions. That's why when we write here, we write the condition down here. It needs to be the intersection of all conditions. Make sense? Okay. Here is a property of trigonometric functions, because sometimes we need to use these properties to deal with the trigonometric functions when we do the Laplace transform. But guys, you don't need to worry about that, because all these 12 formulas are provided in the exam. Okay, they are all provided in the exam, so don't worry about that. Okay guys, let's try finding the Laplace transform of psi 2t to the power of 3. Okay guys, you may notice that if you want to find Laplace transform of psi 2 3, you don't have formula for that. We have formula for the Laplace transform of psi, but not psi to the power of 3. Right? Here it's the same as Laplace transform of psi 2t, psi 2t, and psi 2t, like that. Okay, it's the multiplication of psi 2 3. Okay, so we don't actually have formula for that. Okay, we don't have actually formula for that, so we need to somehow use the properties of trigonometric functions to somehow apply the formulas that we have. Okay, so basically, note, we need to get rid of 3 here. We need to somehow get rid of 3 there. Okay, so this is a technique. First, I'll just look at ft, which is psi cubed 2t. And can I write like this? It's psi squared 2t times psi 2t. Okay, and that is okay, isn't it? It's psi 2t to the power of 3, right? Okay, so I split it. I split 2 of them and 1 of them. 2 of them and 1 of them. Okay, and guys, we have the formula. Psi squared a is 1 minus cos 2a divided by 2. Okay, so in this case, this is a. Okay, so we can change that to 1 minus cos 2a, right? That will be 4t. Make sense? Because right now our a is 2t. Okay, it's psi squared a. So a now is 2t. So here it's 2a, which is 2 of 2t, which is 4t. Okay, divided by, what is it, 2. And then here we also have psi. We still have psi 2t. Make sense? So in that case, we have sine 2t divided by 2 minus cos 4t sine 2t divided by 2. Okay, guys, you can see here, if you apply the Laplace transform, it's just the Laplace transform sine, right? It's not sine squared, it's not sine cubed anymore. But the only problem here is the second part. The second part is still the product of sine and cos, and you can't really apply the Laplace transform. So you need to somehow change that. Okay, but we have the formula. We have this formula, which is sine and cos. Sine and cos is 1/2 sine sum plus sine diff. Okay, 1/2 sine A plus B plus sine A minus B. Okay, oops, I think I have a typo here. It should be A and B. My bad, sorry. It's sine. Okay, just change that in the note. Okay, my bad. I'm so sorry. So here, this guy and this guy, we look at cos sine. Do we have cos sine there? No, we don't have cos sine, but we have sine cos, right? So we just, do it one more time. Change it to sine 2t cos 4t divided by 2. So we look at that as A and that as B. Make sense? Make sense? So here we have that it's sine 2t divided by 2 minus sine. Okay, here we use this formula, sine A cos B, which is 1/2 sine A plus B sine A minus B. Okay, okay, so it is 1/2 sine A plus B, that will be 6t, plus sine A minus B, that would be 2t minus 4t, that would be minus 2t divided by 2. Okay, and that becomes sine 2t divided by 2 minus 1/4 of sine 6t. Guys, here we have that sine of, we don't have this formula, but guys, you need to know sine of minus A is minus sine A, and cos of minus A is actually cos A. Okay, okay, you probably need to add those two formula there. Sine of minus A is minus sine A, and cos of minus A is cos A. But you don't have this formula in the exam, so you should know. Okay, okay, this one you should know, the one in the red. So here we would have that it's actually minus, right? Because it's sine of minus 2t, that would be minus sine 2t, and it becomes sine 2t divided by 2 minus sine 6t divided by 4 plus sine 2t divided by 4. And then the Laplace transform of sine 2t cubed would be the Laplace 1/2 Laplace transform of sine 2t minus 1/4 of Laplace transform of sine 6t, and then plus 1/4 of Laplace transform of sine 2t, and that becomes 1/2 Laplace transform of sine 2t, sine kt, right? Sine kt would be, what is it? Laplace transform of sine kt, that's k divided by s squared plus k squared. So it's k, which is 2, divided by s squared plus 2 squared, which is 4. Okay, and that condition is s is bigger than 0. And then we have minus 1/4 of 6 divided by s squared plus 36, and the condition applies s is bigger than 0. And the last one would be 1/4 of 2 divided by s squared plus 4, and the condition is the same, which is s is bigger than 0. So the 2 cancel out, so we have 2 here. And guys, if you can see, these and these are the same. Okay, they are the same. So we can take the sum of them. So we have 3 divided by 2 sine squared plus 4. Okay, this guy is from this and this. Okay, 2 of them together. Okay, and the rest would be minus, okay, here it becomes 3 divided by 2. So we have 3 divided by 2 s squared plus 36 when s is bigger than 0. And that's it. Okay, hope it's not too hard for you guys. Okay, and guys, that's it for the first section, which is the basic of Laplace transform. Okay, let me do some recap for you. First, we look at the definition of the Laplace transform, right? The Laplace transform of ft is integrate 0 to infinity e to the minus st ft dt, and that is the function of s. Sometimes we call it big F s. Okay, and then we did some examples, right? We evaluated the Laplace transform of 1, which is 1 over s. And if we have the table, we don't need to do that, right? We know that is 1 over s. S is bigger than 0. Okay, and we do Laplace transform of for a couple of functions, right? Including these functions. And after that, we look at the table of the Laplace transform, which can help us to evaluate Laplace transform quickly. Okay, we don't need to go back to the definition, right? The integrate of blah blah blah. We don't need to do that. Okay, we can just use this function. Make sense? And we have the conditions here as well. Okay, and we have the property here that the Laplace transform is actually linear operator. So if you have the Laplace transform of f plus g, is you can distribute, you can find the Laplace transform of f plus the Laplace transform of g, and the Laplace transform of kf, you pull k out, you get k Laplace transform of f. Okay, after that we applied the formula to these functions, right? But you need to be very careful, because you may need to do Laplace transform for many functions, and they might have different conditions. Okay, in that case, you need to take the intersection of the conditions. Okay, and that would be the condition for the answer. Make sense? After that, we evaluate the Laplace transform for this function. And as you can see, is e to the something minus e to the something squared. Okay, so we can't really apply Laplace transform, right? Because it's a linear operator. Okay, but the function squared is actually the function times function, right? So we can't really apply the Laplace transform. So we need to use that formula, a minus b squared, which is a squared minus 2ab plus b squared. Okay, so that this function becomes this. And in that case, this function is just, plus and minus, right? Minus and plus. So we can apply the Laplace transform to each function. Okay, and again, guys, when you apply Laplace transform to the exponential functions, you need to be careful of the conditions. The condition that you need to answer is the intersection of these conditions. Okay, and we look at the properties of trigonometric functions. Okay, we have 12 conditions plus the 2 conditions that you should know. Okay, you should really know it. Okay, but the last 2 conditions, they aren't provided in the exam, so you need to know them. Okay, then we look at the last example when we want to find Laplace transform for psi 2t cubed. Okay, guys, we know how to find Laplace transform for psi 2t, but not psi 2t cubed. Okay, because psi 2t cubed is actually psi 2t times psi 2t times psi 2t. So if you want to evaluate that function, okay, you need to evaluate the transform. You need to get rid of the exponents here. Okay, and we can do that using the properties in the previous page. Okay, first we split it to squared and the one without the squared or cubed, and after that we apply the formula, and we apply the formula again. So this guy can actually be written as this, without any exponents, see, without squared, without cubed, and then we can apply Laplace transform. Okay, so in exam you need to be careful. If you see trigonometric functions, squared, cubed, to the power of 4, to the power of 5, you need to somehow use the properties to reduce the exponents to 1, so that you can apply the fundamental formulas. Okay, guys, in the next video we're going to be looking at the techniques used to compute Laplace transform. Okay, for some functions, guys, we can't really apply Laplace transform to them, or we may not have formulas for them. So we need to use some techniques, okay, to change them to some other functions. Okay, we need to use techniques to change them to some other function, so that we can use the formulas that we have to evaluate the Laplace transform. Okay, we're going to be looking at that in the next video. Okay, guys, that's it for today, and don't forget to read a lot. Okay, if you have any questions, contact me, we can talk about that, and do exercises. Okay, try to practice, guys. Practice makes perfect. That is not wrong, it's completely right. Okay, and see you in the next video, guys. Bye bye.